Hello friends, welcome to my YouTube channel, Paul Mathematics Academy. So this is advanced calculus. We want to prove this relation, the integral running from 0 to 1 of x raised to the power of x dx is equal to the sum of n running from 0 to infinity of minus 1 raised to the power of n over n plus 1 raised to the power of n plus 1. So I want to prove this relation if it equals or not. Now I will like to recall that x is equal to e raised to the power of natural log of x. Now x raised to the power of x is equal to e raised to the power of natural log of x raised to the power of x. Now remember this indices rule. Natural log of a raised to the power of b will give us b natural log of a. So e raised to the power of natural log of x raised to the power of x will give us e raised to the power of x natural log of x. So our integral becomes integral running from 0 to 1 of e raised to the power of x natural log of x dx. Now I would like to recall this sum. Now we recall that e raised to the power of z is equal to sum of n running from 0 to infinity of z raised to the power of n over n factorial. Now where z is equal to x natural log of x in this our expression, so I have integral of 0 to 1 of sum of n running from 0 to infinity of x natural log of x everything raised to the power of n over n factorial dx. So bringing out the constants, so I have sum of n running from 0 to infinity of 1 over n factorial of integral running from 0 to infinity of x ln of x raised to the power of n. Now so our integral becomes sum of n running from 0 to infinity of 1 over n factorial of integral running from 0 to 1 of x raised to the power of n natural log of x raised to the power of n dx. Now let's do some substitution. So let natural log of x is equal to minus u. So if natural log of x is equal to minus u, x is equal to e raised to the power of minus u. So we have dx is equal to minus e raised to the power of minus u du. So now my limit will change. Limit of 1, when x is 1, I have ln of 1, which is 0, so u will be 0. And when x is 0, so I have ln of 0, which is infinity. So this will be infinity, this will be 0. So you have sum of n running from 0 to infinity of 1 over n factorial of infinity running to 0 of, now my x is e raised to the power of minus u, so I have e raised to the power of minus un. Now my natural log is now minus u, so I have minus u raised to the power of n. My dx is now minus e raised to the power of minus u du. So bringing out, okay, wait, now this negative, and I want my infinity to come up, my 0 to come down. So this infinity for it to come up and 0 to come down, so we have to eradicate this negative. So I have sum of n running from 0 to infinity of 1 over n factorial of integral running from 0 to infinity of e raised to the power of minus un minus u raised to the power of n e raised to the power of minus u du. Now using the indices law, if we have e raised to the power of b times e raised to the power of c, it will give us e raised to the power of b plus c. Now we are going to use this relation for this and this. So I have sum of n running from 0 to infinity of 1 over n factorial integral of 0 to infinity of e raised to the power of minus un minus u raised to the power of n du. Now, we know that minus u raised to the power of n is equal to minus 1 raised to the power of n multiplied by u raised to the power of n. So, we have sum of n running from 0 to infinity of 1 over n factorial of integral 0 to infinity. Now, factorizing minus u out, so I have e raised to the power of minus u into bracket n plus 1 multiplied by minus 1 raised to the power of n u raised to the power of n du. So, bringing out the constant, so I have sum of n running from 0 to infinity of minus 1 raised to the power of n over n factorial of integral running from 0 to infinity of e raised to the power of minus u n plus 1 minus 1 raised to the power of n u raised to the power of n du. So I would like to do another substitution here. So let u into bracket n plus 1 equal to k. So my u will now be equal to k over n plus 1. So du is equal to dk over n plus 1. So my limit doesn't change here. Now I have sum of n running from 0 to infinity of minus 1 raised to the power of n over n factorial of integral running from 0 to infinity. Now, so here u into bracket n plus 1 is now k. So I have e raised to the power of minus k. So u here is now k over n plus 1. So I have k over n plus 1 raised to the power of n. Now my du is now dk over n plus 1. So I have dk over n plus 1. So now writing this, so I have sum of n running from 0 to infinity of minus 1 raised to the power of n over n factorial integral of 0 to infinity of e raised to the power of minus k raised to the power of n over n plus 1 raised to the power of n dk over n plus 1. So these and these have the same base, so I have to add the exponents. So I'm bringing out the constant out. Now I have sum of n running from 0 to infinity of minus 1 raised to the power of n over n factorial into bracket n plus 1 raised to the power of n plus 1 integral of 0 to infinity of e raised to the power of minus k raised to the power of n dk. So this gamma function. Now integral of 0 to infinity of e raised to the power of minus k raised to the power of n dk is equal to gamma of n plus 1, and gamma of n plus 1 is equal to n factorial. So I have sum of n running from 0 to infinity of minus 1 raised to the power of n over n factorial multiplied by n plus 1 raised to the power of n plus 1 multiplied by n factorial. So n factorial cancel n factorial. So this is equal to sum of n running from 0 to infinity of minus 1 raised to the power of n over n plus 1 raised to the power of n plus 1. Therefore, our relation is right. This is equal to this. So if you like this kind of video, please like, comment and subscribe to my channel, and share the video with your friends that also like mathematics. I love you all. God bless you. Amen.